Okay, they said a circle of radius 1 cm is inscribed in a quarter circle as shown. Find the area of the shaded region. Okay, you know the area of the shaded region will be area of the quarter circle minus that of this small circle. And there is a formula that relates the radius of a quarter circle, that's the radius of this complete circle, and that of this, the one inscribed in the quarter circle. So let R be the radius of the quarter circle, and R be the radius of the small circle. Then R is always equal to root 2 plus 1 times R. Yes, that's the relationship connecting the radius of this big circle and that of this small circle. That's the quarter circle, or the big one, and that of this. So from here, to find the area shaded now, area of the quarter circle minus area of the small circle, which is now equal to area shaded is now equal to pi r squared over 4. Remember, we divided by 4 because this is just a quarter circle, minus pi r squared. And we've noted that big R is always root 2 plus 1 times small r, so all squared over 4 minus pi r squared. So we have that the area shaded is now pi root 2 plus 1 all squared r squared over 4 minus pi r squared, as you can see. So this square affects this and this, so this square times this square, so we can factor pi r squared, and we have root 2 plus 1 squared over 4 minus 1, which is the same as pi r squared times this thing is 3 plus 2 root 2 over 4 minus 1, which is pi r squared. LCM is 4, so I have 3 plus 2 root 2 minus 4. So which is equal to 2 root 2 minus 1 over 4 pi r squared. So that's the area of the, but they told us that the radius of the small circle is 1, so r is 1. Therefore, this is 2 root 2 minus 1 over 4 pi. But looking at the option, there's nothing like that. So it means that they substitute, as I'm seeing, over 14 and 22. So they substituted pi as 22 over 7. So I have 2 root 2 minus 1 over 4 times 22 over 7. So 2, I have 2 root 2 minus 1 over 2 times 11 over 7. So which is 11 times this is 22 times root 2 minus 11 over 14. So the answer is option C. So remember, I didn't start the question formally. I've known a formula connecting this kind of situation, that the radius of this big circle is always related to the small one. That's the formula. So that's what I use. So let me prove that r is equal to root 2 plus 1 times r. Okay, look at this. That's similar to the other diagram. So they are the same. So let's call from here to here, that's the radius of this big cell. Let's call it r. So let's the middle of this. Okay, let's join these points to this. So let's add auxiliary lines. So I've added the auxiliary line. So this is the center of this circle, and if we call this small radius, so from this, this is 90. See, they are all 90. So you can see that this distance, let's call it O. A. This distance is r times root 2. That's root 2r. And this is also the radius r. So that's it. So from here you can see that this is the total. This is also big letter r. Do you get? No, this is also the radius of the big circle. This is also the radius of the big circle. So we can easily see that root 2r plus r, that's this plus this, is big letter r, and we can factor this as root 2 r times root 2 plus 1 equal to r. So that's how I got the formula I used. Yes, so that's a very nice question. Thank you.